Alright, now we're going to talk about section 1.2, linear equations in one variable. And we're going to look at, the basics of algebra in this case. And that's looking for a pattern and looking for an unknown. So we have to identify different types of equations, so we're going to be doing that. We're going to have to solve linear equations in one variable. We're going to have to look at rational equations and actually compute x and y intercepts algebraically. And if we look at the three types of equations, conditional, contradiction, and identity, then we can, these are just fancy words to indicate the various nature of things. Like, for example, if I looked at this conditional statement right here as x squared minus 9 equals 0, well, the only solutions to this would be negative 3 and positive 3. And that's what makes it conditional. That this equation is conditional on the fact that negative 3 and 3 would make it a true statement, because that would in fact make it 0. If we look at contradiction here, we can clearly see that 1 does not equal 3. And there is no way that a real number will ever make this statement true. And if we focus in on the identity, we have this wonderful BC here, which does state almost the same thing as the conditional example here, but there is a much bigger difference, in which case we have the factors. So we have the factors equaling the standard form, if you will. And this works for any real number. Okay. So if I just look at the basics of solving equations, then we know PEMDAS. And I'm going to circle the MDs and the ASs because those are inverse operations to one another. And then I'm going to make a little mental note on that I have to go in reverse to solve. So if I just have something like 3x plus 5 is equal to 11, then all I have to do is read this. That says 3 times some number, then add 5. Then all I have to do is the exact opposite to the 11. So what's the opposite? Well, I have to subtract 5, and then I have to, so I'll write it down, subtract 5, and then I have to divide by 3. So x in this case is 2. And that's pretty much the, if you have more terms everywhere, just combine them on the left hand and on the right hand, and then isolate them, and then do the same process. Okay. So there is one thing, though, to be careful about extraneous solutions with dealing with rational expressions or equations, okay? So let's move on to finding intercepts, and that's easy. If we want to find the x-intercept, we're always going to let the y equal 0, and if we want a y-intercept, we're always going to let the x equal 0. So in essence, your answer will always look something like this, if it's in two-dimensional space, so 2D. Okay? So what's the idea? You know, get an equation and have it set equal to 0, and then find x and y intercepts. Okay? Alright, now let's look at a specific example with solving rational equations. And the easiest thing to do is to clear denominators, so that's what we're going to do. And lucky for us that there is already a common denominator of x minus 4. So that just means we're going to distribute x minus 4 to the first, the second, and the third terms. So if I write it out, what we have is x minus 4 times the quantity, and you know what, let's copy this. Alright. So now what we have is that product that we're going to distribute the binomial over here, and over here. Well, what do you notice that's going to happen to this? Well, you're multiplying and dividing by x minus 4, so those are gone. And what happens over here to this x minus 4? Well, that's also canceled out again, because we are dividing and multiplying by the same gosh darn thing. So if we rewrite this now, what we have is 3x equals 5 times something plus 12. And what did we have to multiply 5 by? That's right, x minus 4. So now all we have to do is another distribution, this time the 5 over the x minus 4. So if we rewrite all this, we're going to have 3x equals 5x minus 20 plus 12. And now all we're doing is combining the like terms. So if I combine like terms, I go back and I write down distribute and distribute up here as well, just so we kind of have an idea of what to go back to. Then it's clear to see that we have 20 negatives and 12 positives, so that's going to make us 8 negatives, with the 5x is all equal to 3x. And then we have to ask ourselves, do we want to solve for a negative or positive variable? And the answer is always the positive. So in this case, what we're going to do is we're going to add 8 to both sides and subtract 3x from both sides. So that just means that we're going to have 8 is equal to 2x. And then if we just divide by 2, we get x is equal to 4. But wait, there's something interesting about this solution, isn't there? Yeah, it's the only value that will not work for this particular problem. So if we can see it from our denominator, so here's our denominators. We have a denominator of x minus 4, but we're saying that our solution here is 4. So if this is the case, we get x minus 4, and let's write it in this way, where it cannot be equal to 0, but x is 4. So what can we say about this? That there is no real solution. So what do we call x equals 4? Well, that is what we call an extraneous solution.